This lesson is called Create a Storm Drain. So basically I've reset the project so that I can show you a few more things. And what we're going to do is just build the storm drain system and save, exit, and run. So you can see that process kind of start to finish. So this is the build the storm drain system from shapefiles. Let's start by grabbing our shapefiles, and they're in here, advanced storm drain layers, and let's just go with shape, and drag and drop. And then I'll minimize that. And Robson made new code that when you add layers to the project, it adds them to the top of the layers group so that you don't lose them, because they're added somewhere down here in a group. So what I like to do is I like to pick them up and drop them into the storm drain group. And once I hit the save button, it's going to give me options. So it's going to say click yes to save the external data to the geo package. Yes results in a larger geo package but eliminates the need to reconnect data paths. Click no to save the external paths to the QGZ file. So I'm going to click no. Well, actually I'm going to click yes because I want to show you that you have multiple options. So I click yes, but I'm not going to actually add these guys sorry, let's try that again. No, it's not a shift. It's just a click and drag. Okay, it's not a shift. I'm not going to move these over to this group because I don't want these to be part of the geo package. Because once I use these, I no longer need them, and that's new. Okay. Previous plugins, you needed these layers and you needed to do all of your work in these layers, but that's not the case anymore. So I'm going to click OK and leave them on the user layer side. And what that means is that when I'm finished with them, I can just right click, remove layers, and then save again. But whereas if I had moved them to the geo package, I would have to manage them from this side and I would have to delete them over here. But I don't want to do that because I don't want my project to be, I don't want these layers to be part of my project because I'm not going to use them anymore once I do this processing today. Okay, so let's go ahead and move on with the system. So let's go ahead with Storm Drain Editor, and then we go to this button right here, which is Select Components from Shapefile. Okay, and what we'll do is we will point all of these fields to the respective fields in these layers. Now if I click the drop down menu, you'll see that there's only a handful of potential layers, so it's filtering this field by point type data that has a single feature in it. So this goes to inlets and junctions, and then the secondary smart code will fill these fields, and it's guessing, right? Because the names will not always be the same. This is the data that you need, and these are the fields, the potential fields with that data. Okay, so inlet name goes to a field called name. Inlet type, and it's a string. Inlet type, and it looks to me like there's only one string type field in that entire shapefile, so that's when you hit the drop down button, it only gives you one. That's interesting. So type is integer, 0 through 5. Invert elevation is a real number. Maximum depth is a real number. While these two fields are inside my shapefile, they don't actually have any data in them. They're both null. So I can either leave them selected and they will just write null data to the tables, or I can uncheck them and they will be skipped and the tables will be set up by the Storm Drain plugin. Or sorry, the FLO-2D plugin. Length perimeter, width area, this one's wrong. This is not curb height. This should be set to the height sag surcharge variable. Height sag or surcharge. Of course it's a shapefile, so you are limited to like a string. The field name length is limited. That's why it's cut off. GeoPackage field names have a lot more space that you can write to the name. Weir coefficient, feature, and then curb height, clog factor, and clog time. Again, these are null. So I can either keep them on and they'll just be null, or I can turn them off and they will not be used. And then Dropbox area does have some data in it just to show the process of how to set up Dropbox area. All right, now what do we have? Outfalls, and this is outfalls, and this is name, invert, elevation, flapgate, allow, queue, and type. And these are all null, so I can turn all three of these off. Type, this would be a string, so it's free, normal, fixed, tide curve, tide series. Allow queue is either, it can be a string or an int, but basically it's a 0, 1, or 2 is the allowed values. Flapgate is on or off, so that's a string. The string is either on or off or yes and no, but I think it's probably on off. Invert elevation, that's a number, real number, and name is a string. Okay, we'll go to storage units. Storage units with FLO-2D, the INP needs a lot of data, but the FLO-2D storm drains don't use some of that data. So name is okay, invert elevation is okay, max depth is okay. Initial depth, that's null. External inflow, a null. I just don't have any external inflows or initial depths for my storage units. This is evaporation factor. FLO-2D doesn't use evaporation factor, and so you would just leave that blank. Treatment, FLO-2D storm drain does not use infiltration, but the data has to be there for the INP so that you can open the INP and run the swim GUI if you want to look at your data in the swim GUI. So don't need this, don't need any infiltration information. Our storage curve, this is a field that contains a value that is either tabular or functional. Since ours are all tabular, our coefficients can be, we don't need any coefficients. And then our curve name is tab curve, but the name is storage 1. Okay, conduits. Now for all these three, these are the links. So these were the nodes, or these were nodes, and these 4 are links. So we will click conduits, and for all of these 4, you no longer need this from or to nodes. We will be filling those in at the last. Okay, so the name is okay. Inlet offset is good, but that one's wrong. So we're going to change that one. Shape is okay, barrels, max depth is okay. Geometry 2 is okay, but we didn't actually fill in all of these because this project only has circular geometry. So if you want to just turn those off, those will be filled in with either nulls or zeros. I think they're filled in with zeros. Length is okay, Manning's N is okay. No initial flow depth, that's a null field. And I don't have a maximum depth, that's a null field. The fields are there, but so that you could use this as your own template, but they're null. Okay, these all 3 are null, so I will just uncheck those, and flapgate is yes or no, and I think you need this, and they're all set to no. Okay, bumps. For that, again, don't need those 2. Initial status, start depth, this one is wrong, so put that to stop depth. It's probably looking for the word shut off. And then curve name, that one's done. Oh, these 2 are not connected because you have to set all this stuff up down here, okay? Orifice. And name, don't need them. Type, you do need this inlet offset. That is the distance from the base of the structure to the top of this geometry, or to the opening geometry. That's what that inlet offset is. Discharge coefficient, flap gate, time to open, close, shape, height, width. Okay, weirs. Name is okay, don't need those 2. Type, this is wrong, needs to go to inlet offset. This needs to go to discharge coefficient. Flap gate is okay, end contraction is okay, end coefficient is wrong, side slope, shape, height, length, all of those are okay. So we go ahead and click. Now if you've got everything right, you're going to click assign selected fields. And I'll click assign selected fields, and then we should see some messages. So there's one message that says weir coefficients in the shapefile are outside the limited range, and inlets and junctions are outside the computational range. and we have conduits that are outside the computational domain, because this project has a few features that are outside the range, so that you can see how to set up features that might be off-site. Okay. Now this says that links with no inlet or outlet, none of our links have an inlet or an outlet because we turned off all those fields. So click OK, and let's talk a little bit about these features that are off-site. Okay, you can have, let's identify these features. You can have a feature that's off-site so long as it does not try to connect to a grid element. So the feature has a name J, that means it's not going to connect to an inlet. And then down here I have some outfalls, but they are, whoops, sorry, wrong one, wrong group. Okay, and they have the name O, which is an outfall, is fine, but their allow queue type is 0, meaning that any flow that flows through these will just act like a sink. It'll just flow off the system at a free discharge. Okay, so that's what those do. So they can be off-site. That's okay, as long as they're not an inlet that starts with I or an outfall with allow queue equal to 1. Okay. All right, let's get on to the next step in the process. Here, let's just do this zoom to layer, and which is to auto assign the links and nodes. So what this is doing is it's going to assess each link, and it's going to assess the start of the inlet, and it's going to assess the end of the link and look for an outlet, and then it's going to assign it. So you want these numbers to match. If the numbers match, everything went well. If the numbers didn't match, it will give you a list of data that you need to go to, and so you can go find the data that was broken. So what this tool does is it looks for a conduit. So let's get on our conduits, and we're kind of done with these, so let me uncheck these real quick because we're kind of done with those. So if I ID this conduit, what's going to do is, as you can see, that this is the conduit we're on right now. This conduit has a initial vertex and a final vertex. And what this tool does is it finds the node that's closest to the initial and the final vertex, and it sets it as the inlet and outlet node. So why is that important? Because if, I'm going to do this right here on this one, if your line direction is inverted or reversed, I'm going to show you what I mean by that by clicking this tool, and I'm going to right click, oops, sorry, no, I'm going to click the vertex editor. No, I'm going to click right click, make sure that my advanced digitizing toolbar is on, and then I'm going to find the reverse line tool and just click that. So if this node is in the wrong, or sorry, excuse me, if this polyline is in the wrong direction, that means that that the nodes will be wrong. They'll be set up incorrectly. So the inlet node will become the outlet node, and etc., because it's finding the last node and the first node, and it's finding the closest node to those within 3 foot. Okay, so that's one problem. So make sure that your points are always pointing in the right direction. I'm going to reverse that again, and you also need to make sure that, let me show you, if this vertice, if this last vertice right here, let's get this one, is off by more than 3 feet, it's not going to find its node. And so it's going to give you an error. So make sure that when you're digitizing these guys, make sure that you're using your snapping toolbar. Okay, so that's right click, toolbars, and then down here is snapping toolbar, and just make sure that you're snapping these points together like that. Okay, and let's go ahead and turn off my snapping tool, and I'm gonna turn the editor off and discard the edits and move on to the next process. Okay, so then we have this, we don't need this because that data is already filled in, and this, and then our last thing that we do will be assigning this data right here. All right, so let's go over these groups now. So let's start with the type 4 inlets. So if I go to the storm drain editor Over here, I see that I have the type for tables area right here. And what this does is it shows you how to set up a single table for type 4, or if you have many tables, it'll show you that method. So if you have a single table, you can use this button to add the rating table, and then you can just assign the rating table manually. If you have a single culvert method, same thing. You're going to add the culvert, you're going to assign a new culvert equation, make it, the name should match one of your type 4s. If the name is wrong, like if you mess up this name right here, it'll tell you, hey, there is no inlet with that name. You need to fix something, and then fill in the culvert data. So C diameter, the culvert type, entrance type, Q base, malt barrels. Okay, and I think this is wrong. I think this is 1 or 2. So I'll have to check that with Noemi, but I think that should be 1 or 2. All right, so let's well, and we'll check that once we run our model. So let's go ahead and do this. So now what I have are rating tables already defined. And I'm going to open these rating tables in Notepad++ so that you can see what they look like and how to create them. So rating tables, as long as the file name is the name of the structure .txt, and this is just depth on the left and discharge on the right. And this is a type 4 culvert equation. Name, this would be height, so that's kind of like max depth of the culvert. Inlet, it's the pipe, right? It's the inlet pipe. The type, I'm going to say type 2, which is circular. This is the entrance type, and I'm just going to say that it's a square, like kind of like a flush head wall. And then the width is 0 because it's not a rectangle. And then the malt barrels is 1 because they only have 1 barrel. And you do, I believe you may need these guys up here too. This data that will be ignored by the processor. Okay. Okay. So what you get here is what you'll do here is you'll open this, and you will find those files, rating tables, and you'll find that one and click open. And it will tell you that one rating table is imported, and it'll give you a warning file here. And then you'll do that again, and you will do the type 4, get that again, and it'll say that 5 culvert equations were imported. Now let's take a quick look at our inlets and junctions. So I'm going to open our inlets and junctions, and I want to dock that window, but maybe I want to dock it like right here. Okay. So what you see here, let's maybe do this. Okay, what you see here, oops, and is an inlet type, and we'll just go, well, let's just sort by inlet type, and then we'll go find the type 4s. Actually, I think you can do that if you're in here searching by inlet type and you know what you're looking for, just type the 4, and that usually takes you right to what you're looking for. And so what we are looking for is to see that these individual guys are listed in this list, right? So that one's good. And then if you look, that's that rating table. And then that's your culvert equations for 41. So that's for this one. And then here's the one for 44. So that's for this one. And of course, when I select those, I'm selecting them down here. So let's see, type 4. Oh, you can't see it. Even like, no, I'm sorry, it's not down there. Where are those? Well, I forgot where they were. Zoom. Oh, there it is. There it is right there. So they're all kind of in this area right here. And those are all the type 4s that we have. So diameter, entrance type, so it's a box, it's a circular culvert, so that gets 2. And then entrance type. And then of course, if you want to figure out these variables, you go to the data input manual or the storm drain manual to see what these variables should be. Now, the next thing we need to do is define the pump data. So we need to add a pump curve, and we need to rename that pump curve P1 because that's the name that we defined in our pump table. And then this goes to a depth and discharge, and the description 20 CFS, and we just put our data in here. So 1, 10, and 20, 20, and as soon as I click off that cell, the data is saved. So there's no save or commit or anything buttons on here, because as soon as you modify the data, it's saved. Okay, let's close this one, and now let's open that pump. Right click, open attribute table. See here, our pump curve was named P1. Okay, and so that is our pump curve data for P1. And we also had one more thing. We had a storage unit. We have 3 storage units that we need to define the data for. So let's right click, open attributes on our storage units. Let's go ahead and dock that. And let's go ahead and zoom to this layer. And these are our 3 storage units right here. So this is a little bit different. Accessing the editor for these is a little different. You'll do that by going to the FLO-2D info tool, and then you'll select the storage unit, and you can see here that you have the storage unit data. So what are we looking for? Oh, it's actually not on here. The properties are not on here, but let's see. They probably are on here. Tabular. Yeah. Oh, it's capital S, storage 1. Well, that's fine. So here's where we need to define our inflow data, or sorry, our storage data. So we click this, and this goes to, let's see, storage 1. Looks like it was a capital. Storage 1. And I don't think we need a description because that is in the file. So what I have here is a storage table, and I exported this from EPA Swim. I wish I could save that so that stops being the wrong spellings. Okay, and this is depth versus area table. Okay, so what we do is we click load file, and we go that guy right there. And the name, I think I had to add that name. Then the description comes in, and the table comes in, or you can copy paste the data from Excel or any other tab delimited data. You can copy paste it into this table, and then you just click OK. Now let's see, we are finished with our storage curve, but now what we need to do is maybe click all of our storage units and make sure that they are all assigned to storage 1. Okay, and they should have already all been assigned to storage 1 because they already had that name in their table, so they would have been fine. So that you would only had to reset them if we had changed that name. And that is how you would define a storage unit data. And the final steps will be to, I think, set the storm drain control parameters and schematize the data. So we set the storm drain control parameters. For this project, I use default parameters. I don't need to change anything. So your start date and start time will be the start of the simulation, and your end date and end time would be, in this case my simulation time is 10 hours, so that'll just be 10 hours after this time. So that's important. So if you have like 48 hours, you need that to be reflected in this table, and it should be, because this is defined by your start time. Now, if you have dates inside any of your storm drain time series data, you can either remove those dates out of that and start it at the simulation time, or you can change the dates in here to reflect the dates that are in your time series data. Okay, because if you have dates in your time series data, it will need to sync with these dates, otherwise your time series will not be activated. Okay. Oh, and your report step you can modify, but we always set it to this simulation output interval, but you can change that to whatever you want. Advanced parameters, these are the ones that you can modify, and these are hardwired, so it doesn't matter what you have in here. FLO-2D sees that the project is in feet from the coordinate system, so it uses CFS. And so if it saw that your project was in meters, it would use CMS, cubic feet per second or cubic meters per second. We don't use liters or gallons or any of the other weird flow units you might see in a storm drain model. We only use a dynamic wave equation. We always have it set to partial inertial damping, and we always have the normal flow depth limited to both. So even if you modified these in the INP, if you modified any of those in the INP, it would ignore your modification. This one, of course, wouldn't ignore it. Now, steady state, we always, these are default. You can choose these, yes or no. You can choose the equation. And of course, I have depths as my link offsets, but if you want to use elevations, you can choose that. And my minimum slope is default. Click OK. And now I need to schematize the storm drain. Okay, so you saw as soon as I hit that schematize button, what it did was it created the data that's going to fill the swim out f.dat and the swim flow.dat and the Dropbox dat file, and if you had clogging data, it would fill also the clogging data out once you hit the schematize button. That's where all that data gets committed to the FLO-2D data files. Okay, now let me just zoom to layer, just reset that, and I think we should be ready for a run FLO-2D. And then that'll be the end of this video. Then we'll move on to looking into some of these other editors. So let's click Quick Run. We're going to go Quick Run, and then we are going to set this to our self-help video test. Let's make sure that that is empty. Yes, it is. And then I'm going to click Select Folder and OK. And then let's grab that folder again so we can see that that is filled up with data. The run, as soon as the DAT files are written, the run is executed, and you can see that it starts running. So if you get an error message, you'll go and I would say skip to another video that says FLO-2D review or FLO-2D troubleshooting or something like that. That'll be a few videos down the road in the self-help kit. Okay, so let's just go ahead and let this run, and we'll come back and do another video where we can see some of these other tools in action.